Hi, have a nice day. This video is taken for EMBETRONIX competition at IIT KHARAGPUR. I am Syed Aslam, doing my final year EEE at Muhammad College of Engineering, Tamil Nadu. And my batchmate is Krishna Balan, doing his final year ECE at Government College of Engineering, Salem. Now let us see the making of LED and switch module, which will be placed at the car parking slot. This is used for the purpose of status setting and the indication of vacant and non-vacant of the slot. These are all the components required to make this module. This is the complete switch and LED module, which should be placed at car parking slots.
Hi, I am S. Krishna Balan. I am the partner of Syed Aslam. I am going to show you how I make the IR module that is used at the front of the parking entrance module, which is going to detect the incoming vehicle automatically. These are the components that is required for making the module. This black one is the photodiode, and I also have the IR emitter. I'm going to solder the IR emitter in this board and the receiving module in this board. This is the module of the IR emitter. This is the complete module of the IR receiver. This is the IR module. This one is the IR emitter and this one is the IR receiver. Now it's going to be placed at the parking entrance. Now when the IR ray is cut by the vehicle, then the light glows as shown. So this is the testing of the IR module.
This is the parking entrance module that we have made for our EMBETRONIX project. This is the application board. For the purpose of our project, we are using PIC 16 of 877A 40-pin 14K word microprocessor. This application board was soldered by us. This is the RF module that we bought. This is the power modulating circuit which we built for this RF module. This is Zigbee Pro, which is based on the Zigbee architecture, and the name of this is XP Pro It has a capability of 2.4 gigahertz, which can range up to 300 meters. This is the antenna that need to be connected with this Zigbee Pro, and the final RF module will look like this. And this need to be connected to the RX check pin of our microcontroller. And this LCD display is for the purpose of displaying the customers or the car users about the nearest slots and the number of empty slots. This is for the purpose to select the slot which they want to park the car in the optional mode. And this is an extra additional feature which we have added. And this is the IR sensor. Whenever the car cuts, it detects and gives a signal to the microcontroller. Depends upon that, the servo motor will be controlled and a gate arrangement is used so that the car can enter into the parking entrance area.
This is the parking area simulating module. This is the plywood. We have to plot at the plot numbers. This is the module which is going to be placed at each slot. It consists of a switch and the 3 LEDs, one to represent vacant and one to represent non-vacant, and another for the reserved. These 2 slots we have added it for an optional feature. It includes the IR pair, which is going to direct the vehicle automatically. This is the application circuit for the parking area simulating module. This microcontroller is going to control all these switches and also the RF module.
Though in the problem statement, it was given that the vacant and non-vacant decisions for the slots will be done manually. Though to make the project realistic, we have attached two extra slots which will be detected using sensors. This is a basic IR sensor which can even go up to a long distance, which can be implemented in the real time application also. Whenever the slot is vacant, green light will be glowed, which gives a signal that the slot is vacant. A car can come and stand in that position. Whenever a car is placed, the green light goes off and a red light blinks, which means the position is non-vacant. That is, it is filled. And this information simultaneously will be given to the controller for processing purpose.
This is the final hardware module that we have completed till now. Still the software part remains, so that we couldn't show you the working module. This is the parking area simulating module. The red light shows that the positions are non-vacant. The green shows that the position is vacant. It can be switched by a switch, as shown. This LED that is yellow is for the reserved. This is the transceiver, Zigbee. This is the microcontroller which controls all the switches and transceiver, and the power supply unit. This is the parking entrance module. This is the microcontroller which is controlling all this LCD, keypad, and the IR, and also the transceiver, Zigbee transceiver. This is a servo motor which we are going to use for the gate assembly, and we have not connected it yet. It is an external optional feature